So when we're looking at the sampling distribution of our proportions, we're really asking the question, how can we determine how accurate the sample proportion is? A proportion is a ratio, fraction, or percent that's going to indicate the part of the sample or population that has a particular characteristic. We may have seen other examples where we've used ratio scale of measurement. Here, we're going to use the nominal scale of measurement since the outcomes will be limited to two values. So in Southern Tech, we have an example where a graduate either entered the job market in a position related to his or her field of study or not. Married men either felt that both partners should earn a living or they did not. So in each example, an observation is classified into one of two mutually exclusive groups. And so we can refer to the groups in terms of proportions. When we make inferences about a population proportion, we start with a simple random sample of n number of elements selected from the population. Then the sample data provide a value for the sample proportion. This sample proportion value is then used to make inferences about the value of the population proportion. The sampling distribution of p bar is the probability distribution of all possible values of the sample proportion p bar, with the expected value of p bar being equal to the proportion of the population. The formula for the standard error of the proportion is going to depend on if you have a finite population with the finite population is defined as one where the proportion of the sample out of the population is less than or equal to 0.05. So in this case, the standard error of the proportion will include the finite population correction factor in the calculation if we've determined that we do have a finite population. The sampling distribution of p bar can be approximated by a normal distribution whenever the sample size is large enough to satisfy the two conditions, being that the sample size times the proportion is greater than or equal to 5, and the sample size multiplied by 1 minus the proportion is greater than or equal to 5. So if both of these conditions are met, the probability of x in the sample proportion can be approximated by a normal distribution because n, or our sample size, is constant. So here we're going to look at prospective students at St. Andrews College wanting on-campus housing. We want to first know if we can use the normal distribution to find out if a sample of 30 students will reflect the population proportion. So here we look and we see that we have a sample size of n, we have a proportion of 0.72, and so when we do our sample size times our proportion, we get 21.6, which is greater than 5, and then when we do our sample size times 1 minus our proportion, we get 8.4, which is also greater than or equal to 5. If we use the normal approximation and impose the normal curve distribution, we have the expected value of the population proportion, 0.72, and the standard deviation for this curve is equal to the square root of the population proportion multiplied by 1 minus the population proportion divided by the sample size. So this is going to end up resulting in the standard error of the proportion being 0.082. So first we need to find the z-value of that upper endpoint of the interval. And when we do our standard z calculation of x minus x bar over standard deviation, we get 0.61. Then using the z-table to find the area under the curve corresponding to the z-value of 0.61, we then find that that area under the curve is going to be 0.7291. So what this means is that the probability of our value being less than our upper value is 72.91%. The value that we just looked up is going to correspond to the darker area shown here. But remember, we're not looking for this whole area. We're also going to have to consider the portion that will be excluded once we identify that lower bound. So now we're going to follow the same steps to calculate the lower bound of the interval that we followed to find the upper interval. So following the same procedure as before, we find that the area less than or equal to a negative 0.61 z-value is going to be 0.2709. So now what we're going to do is we see that the area under the curve that is less than our lower bound of 0.67 is represented in this image by the darker shaded area. So in order to, we only want to know the area between these two z values. And so we could do this by taking the probability that z is less than or equal to 0.61 and subtract the probability that z is less than negative 0.61. So the probability that the estimate of the population proportion of applicants desiring on-campus housing is within plus or minus 0.05 of the actual population proportion ends up being about 46%. The key thing that you need to keep in mind when you're working with the population proportion is making sure that you convert your proportions to z-scores so that you can use that z table to determine the area under the standard normal curve.